This is a presentation on how to calculate a severity index. This video is in response to an assignment in the course taught by Dr. Farouk Alami at Georgetown Department of Health Systems Administration. The course focuses on health information systems. In this assignment, we were asked to construct a severity index that could be used in conducting causal comparative effectiveness studies. The course is available at the site you've seen on the slide. The purpose of the severity index is to measure the outcome and not the disease, and this is very important to establish. The data that was provided for the analysis was data presenting 10 cases which we will be using to measure the severity index for the particular hospital from which the sample data was obtained. As seen in the table above, we have different types of diagnoses such as MI, myocardial infarction, CHF, congestive heart failure, ACL, hypertension, alcohol use, etc. The first, in calculating, we will eliminate the ACL surgery as seen here because it is a non-interacting diagnosis and it will be analyzed separately. This way we can obtain a more accurate index for the other diagnosis. Again, it is separate from the other diagnosis, and that's why we just take it away for the sake of this analysis. In order to conduct the analysis, we had separated each diagnosis and had calculated how many times each diagnosis had occurred, where the value of 1 was assigned when the diagnosis had occurred, and the value of 0 was assigned when the diagnosis did not occur. The next step, we had calculated the average occurrences for each diagnosis in order to calculate the severity of each. Typically, this can be better calculated using regression analysis. However, because my Excel does not have this feature, I had calculated the averages using the average function instead of regression in order to establish the severity. We can see severity of MI is 0.078, CHF 0.67, etc., etc. After calculating the averages, we calculate the overall severity. This is calculated by subtracting 1 from the indicator value multiplied by the severity times the severity of all variables. As we can see in the formula, for example, overall severity for case number 1, and these are how you do the formula, where H stands for the column H, and H stands for the row and 2 stands for the column. I'll just give you a second to digest the formula and how it's done. As we can see, wherever CHF and MI were diagnosed, the overall severity index is 0.09, which is here. As for MI diagnosis, the overall severity is 0.08. Meanwhile, the overall severity when all diagnoses are found, we have the high severity of 1.0, which makes sense because the more disease the patient has, the higher the severity of the sickness, or the higher the severity is. The data analysis. As we can see in the graph, there is a clear relationship between the severity and the length of stay, despite the isolation of the severity of each diagnosis. By developing a severity index, we can better assess the quality of care provided by first measuring how severe is the illness of the patient before any intervention. This will allow us to better measure the outcome of the intervention provided by initially establishing an accurate reference point, which is the severity of illness, against which we can later compare and measure the intervention and the consequent outcome. Therefore, we can establish the quality of care provided and whether improvement in intervention quality of care is needed or not. Finally, this is a simple method by which we can extract data from the claims department and accurately assess the quality of care and accurate comparative effectiveness.